A string of 20 lights are wired in a series, so that if any light fails, the whole string will go dark. If each light has a probability of 0.02 of failing, and lights fail independently of each other, what is then the probability that the string of lights will remain bright? So the first thing that we should think about is, what is the probability that a single light will remain bright? Well, the probability that any light fails is equal to 0.02 that was given to us. So if we think about the complement, not failing, or in other words, remaining bright, this will be equal to 1 minus 0.02, which is equal to 0.98. Now this is the probability that any individual light will stay bright. We want to know the probability that, let's say, the first light, L1, let's call it that, remains bright, and the second light, L2, remains bright, and the third light remains bright, and ... all the way through to light 20 staying bright. We want to find this intersection. Well, the good thing is that because each light fails independently of any other lights in the series of strings, then we can simply use the multiplication rule for independent events. So the probability of L1 staying bright times the probability of L2 staying bright times the probability of L3 remaining bright times ... all the lights in between times the probability of L20 remaining bright. So now we can simply multiply each one of the probabilities. Because each light then remains bright, the probability of this is 0.98. We simply then multiply 0.98 times 0.98 times ... times 0.98 20 times. So if we want to write this in shorthand, this is simply just 0.98 to the 20th power. This will then be the probability that the entire string will remain bright, because each light has remained bright. So this comes out to be 0.6676. In other words, the likelihood that the string of lights will remain bright is 66.76%.